Hi, welcome. Welcome to the online lectures. This is exercise of the lecture number 2. Okay, the first question is, basically we have to synthesize we have to synthesize this pyrrole from this starting material. Okay, the important fact is that how we can synthesize this pyrrole. Basically, this pyrrole, the first thing that we have to notice is that we have two electron withdrawing groups, two esters, in the position 2 and the position 4. This is a clear indicative that we need to use a NOR synthesis. What we need to do a NOR synthesis, remember we need a 1 keto ester in this case, 1 free keto ester, and then we need a 1 free keto ester with an amino. Okay? We will start synthesizing the 1 keto ester. Okay, we start with ethyl acetate. We do a Claisen condensation. We can use with methoxide. I use methoxide in order to don't get a Kranz esterification. And basically the methoxide makes an ion here that attacks another molecule of the same methyl acetate. Addition, elimination, and I get the 1 free bicarbonyl compound. Then this 1 free carbonyl compound, I have to put a hydroxide here, what I use. I can use this compound to generate an nicroso compound. This basically generates a nicroso compound, and then basically this attacks here. Okay, and then this pair of electrons is going to form a double bond here, and what we generate is the oxime. Okay, what we have to oxime, simply we reduce the oxime with zinc acetic acid, and what we get is the amino in the middle position. Okay? This is basically how to generate this compound, and then we will form the pyrrole. We have here the recently synthesized amino compound, and what we do, this is reacting with another molecule of the keto ester. Okay, that means we have acid media. We activate this carbonyl compound, then the amino attacking here to form the heniaminal, okay, is hemiaminal, then eliminates water, okay, we protonate the alcohol to make a very good leaving group, that would be water, and then we form amine, okay? We form amine and then tautomerization to enamine. We tautomerize this amine to the enamine form, and what we get is exactly this. And then remember, when we form an amine, this position becomes nucleophile and will attack the carbonyl compound that previously we activated with a proton. This is an intramolecular aldol reaction. What we get this compound, tautomerization imine enamine, and then finally elimination of this OH. Basically we protonate the OH in order to get water. Then elimination to generate the final pyrrole. Okay? What is important here, remember that to form a NOR synthesis of a pyrrole, what we need is we start with a ketoester, one free ketoester. We have to do the amination in the middle of the ketoester and then react with another molecule of the ketoester. Okay? Please try to do it at home, try to repeat it, and you will see how it's not so difficult. And remember, if you get lost, what you need to do is to think if you can do an enamine or an imine, and probably you will get in the right way doing this. Not always works, but it's a good advice. Okay? Then we will do the second exercise. The second exercise is basically synthesize this compound. Okay. This pyrrole and this other pyrrole. We need to synthesize these two pyrroles. Well, first of all, we have to decide which method we are using to synthesize each pyrrole. That is important in order to get fast the answer. Well, In order to differentiate between the two syntheses of p-roles that we know, that basically is the PAL-NOR and the NOR synthesis, what we need to do is take a look of the substituents. In this case, we have electron withdrawing group, okay, in the positions 2 and position 4, okay, while here we don't have any electron withdrawing group. That means this will be clearly a NOR synthesis starting from ketoesters, and this will be a 1,4 dicarbonyl compound. We will need to start with 1,4 dicarbonyl compound. If we do a recrosynthesis, in this case what we need to do, this is the easiest way, we break this, what we generate is this is a recrosynthesis. We break this heteroatom, then we break this, yeah, this is the recrosynthesis of this. It's clearly a PAL-NOR synthesis where we start with 1,4 dicarbonyl compound. While if we break this, first we need to break this. We break this bond, carbon-carbon bond, to generate and then we can break, for example, this bond, carbon-nitrogen bond, and what we get is that this is coming from this amino 1 free ketoester with an amino in the middle, and this ketoester, and this can come from okay. These are the two recrosyntheses. Remember that to understand which recrosynthesis we need to use, what we have to do is to check the substituents. If we have electron withdrawing group or two esters in the position 2 and the position 4, this will be a NOR synthesis starting from a 1 ketoester. If we don't have any electron withdrawing substituent, probably will come from a 1,4 dicarbonyl compound of PAL-NOR synthesis. Okay? Then we will do the forward synthesis. In this case, we start with the compound that I draw, the DTN. Okay, I add LDA, that is a strong base with the protonate disposition, and then I add the Michael acceptor, LDA with a protonate disposition, and then this is attacking the Michael, this is doing a Michael addition to generate this compound. I treat this with NBS, water, what I generate is I recover the carbonyl compound, and when we have the one for the carbonyl compound, I add ammonia to generate the final compound. Okay? The mechanism of this last step, you can see it in the lecture, in the exercise of lecture 1. Okay, this will be the forward synthesis. And in the other case, basically, we start with this, we add methoxide, sodium methoxide for example. What it's doing is that we are doing an ion here, and then this is reacting with another molecule of the ester, addition, elimination, and I generate then I need to add an amino here. In order to add the amino, what I will do is I add this compound in acid media. Okay, this is the first step. What I get is the sim. I just grow it the mechanisms a few minutes ago. Okay, and then this compound, zinc and acetic acid to reduce and get the amino compound. Then this amino compound is reacting with the other ketoester, following the same mechanism that I did before. This is attacking here, okay, to form the imine, and then the enamine is attacking this carbonyl group to generate the final compound. Please at home try to do this mechanism from here to the end and from here to the end to get used to these mechanisms. And the most important of this lecture and this exercise is how to differentiate when we are doing Baldor synthesis and OR synthesis. Remember, if we have two with graphene groups in position 2 and position 4, this has a lot of possibilities to come from one free decarbonyl compound, the one keto free ester, okay, or one ester free keto compound, okay. Then what we need to do is to add an amine in the middle and do the reaction. While when we don't have any electron with graphene group, especially in positions 2 and 4, this will come from a 1,4 decarbonyl compound that we need to synthesize using Unpolum. Please revise the notes of Bruno about Unpolum reactions. And that's all. Take care.